So, hello, welcome to day 5 of Advent of Code. Let's get started. Supply stacks. The expedition can depart as soon as the final supplies have been unloaded from the ship. Supplies are stored in stacks of marked crates. But because the needed supplies are buried under many other crates, the crates need to be rearranged. The ship has a giant cargo crane capable of so capable of moving crates between stacks. To ensure none of the crates get crushed or fall over, the crane operator will rearrange them in a series of carefully planned steps. After the crates are rearranged, the desired crates will be at the top of each stack. The elves don't want to interrupt the crane operator during this delicate process, but they forgot to ask her which crane will end up where. Which crate will end up where. And they want to be ready to unload them as soon as possible so they can embark. They do, however, have a drawing of the starting stack of crates and the rearrangement procedure, your puzzle input, for example. Mm-hmm. Moves one from 2 to 1. In this example, there are 3 stacks of crates. Stack 1 contains 2 crates. Crate Z is on the bottom and crate N is on the top. Stack 2 contains 3 crates from bottom to top. They are crates M, C, and D. Finally, stack 3 contains a single crate P. Then the rearrangement procedure is given. In each step of the procedure, a quantity of crates is moved from one stack to a different stack. In the first step of the above rearrangement procedure, one crate is moved from stack 1 to stack 2 to stack 1, resulting in this configuration. Move 1, this is the amount, from 2 to 1, so the top element, okay. Yeah. In the second step, 3 crates are moved from stack 1 to stack 3. Crates are moved one at a time, so the first crate to be moved, D, ends up below the second and third crate. So we'll now have D, N, Z. So it looks like we can use actual stacks here. Then both crates are moved from stack 2 to stack 1 again, because crates are moved one at a time. Crate C ends up below crate M. Finally, one crate is moved from stack 1 to stack 2. The elves just need to know which crate will end up on top of each stack. In this example, the top crates are C in stack 1, M in stack 2, Z in stack 3. So you should combine these together and give the elves the message CMZ. After the rearrangement procedure completes, what crates end up on top of each stack? Okay. And this is really already the input. And then we'll also get the output. which is CMZ. And let's just check. This is actually, I think, quite a step up from day 4. I'm currently thinking, is there actually a trick how to do that? Because we only need the top elements. But I for now would say no. I think we just need to simulate it. Yeah, would actually say so. So, let me just check. We are calling it here already. That's good. So, parsing wise, it also feels pretty complicated actually. To get that parsed, because we have this I think it's because we have all these useless spaces around. Or useless, but they make sense, but they're kind of annoying. So I think the easiest would be if we take a set of these and actually kind of just replace it. Now we can also just scan parts of. I think it's the easiest if we just scan 1, 2, 3. Just take it. We'll take 4 elements and just turn that into strings. I think this makes the most convenient way of parsing, because we can then trim down here, and for the elements, don't really care if we extract it or not. Yeah. So we'll kind of how we find out that. I think we should do the following. We kind of want to store our stacks here. So we will have an array of stacks. And we'll just keep those stacks in a list so we can then easily access them. So let me just check how this is done here. Yeah, we'll keep a map of stacks actually. That's what we will do. So we'll have a map while create, and this is a mutable map of type. Is there a stack in Kotlin? There is. It's the Java stack. Well, you use the array dequeue for that, and we put in the string. And we should be fine, right? Oh, we also need a value. Yeah, well, this is gonna be an int. So, and what we now will do, we'll now take will now take our lines, and we will do the following. We will check if line.starts with move, or let's say not starts with move, because this is what will deal afterwards. For now, we take our line, and then we want to, let's put else here, and we'll call this record moves, and we now want to record the state. Creates state, and therefore we'll in the range, and we'll do it in range, and we'll do range 0, and we'll put line.length, and we want a step size of 4. Input in int range. Is there Kotlin range step size? Can we do something like this? It's written like down to 0 until length, line.length, step 4. So, and bit range could be replaced with indices call. Oh, okay. If Kotlin says so. And we have the step of 4, which is nice for accessing. So we can then send line, substring, start index I, and we want, that's what the substring takes start index, end index, I usually prefer the version with the step size, but okay, I plus 4, and it usually excludes the 4th one, right? So 0, 1, 2, 3 is below. Yeah, that makes sense. And then this is what I'll call create, to put it like that. And we can now take if the we anyhow need to, I will just let's do it like this. Val creates is equal to line.length divided by 4, and then we can here just say for I in creates, and we will do I times 4 times 4 from 0 until, and then we can say creates it. There is something like creates is a map, right? Creates in line. Should not override this. And we can now say something like get or default or get or compute, get or put. Exactly, we'll put the 0 or the that's actually annoying if you have the stack here. We'd need insert it on top, right? I think we can do that. Let's give that a try. And we'll get the key, which is I. And it's a get or put. So we'll should just create the new array deq of type string. Oh, this is a function. Variable, yeah. What is array deq? This has a constructor. Get or put. I think I need to have the variable here, do I? Don't I need this? Kotlin get or put. A bit confused by this thing. Yeah, but why doesn't... I mean, of course I can write it like this, but what's the point of it? I'm a bit not really understanding that. I thought the other syntax is valid as well. Current stack is this one, and for the current stack, the thing is, we want to insert it actually at first. We want to make an add last here because we'll read it from top down. And the current stack, we calculate this is fine. The only interesting thing here is, I will also say we trim it here. And if crate is not blank, then we pick up the crate and do this. However, what we found out here is that let's do it not like this, but we'll maybe not even have an item in the top row. Yeah, this is kind of annoying. So But we can also just wait for a blank line. We'll start with 1 here. So let's say, as long as we don't start with a 1, let's do it like this. If line dot starts with space 1, then we are done with this loop. This is ugly, but just parse moves is equal to false. But if we at some point do not encounter, if a line starts with 1, we say parse moves is equal to true. This is a var. And to then still consume a line, we will then ignore or line dot blank is blank. And we will do this as long as we parse moves. And in here we get the current stack. We can always do that. If the crate is not blank, then we want to add it, but else, no. But else, we want to check if the crates, just do a check here, crates that contains the thing is, if we read an empty crate, then we'll need to be sure that this crate still doesn't exist, because otherwise we kind of fucked up, because the first element, only the first one is allowed to be an element. I just want to have this as a check in there. Check that this contains I. Otherwise, crate is empty. Doesn't contain actually. Is created. Create stack. Stack is created, but crate is empty. And this shouldn't actually happen. So this is just to safeguard us from having fucked up something there. And then we add it at the last element of the stack, which we can then put it away from the first. And for the else part here, we now need to parse those moves. We have a number, so we'll create a small data structure for this data class move, and this is we'll do a from to, and we do also a num. Just call it count int. And from yesterday's reworked example, I somewhere have a regex. Just take this one. We'll declare it. Let's declare it here. This is a move space regex number from second number to other number. That means our regex, we will now use that one here. We say find line groups, and we'll also just regex find line groups, and then we map all our group values to ints. But yeah, doesn't matter. Parts. And then we create a move, and we'll insert it about parts, but we want a from, which is the 1. We have the parts, the 2 is the 2, and the parts, the count is the 3. The count is the 0. And we will keep a move list here, while moves is a mutable list of moves, and we will say moves dot add to this, and this is the parsing part. We could kind of already run it here, but I don't really feel comfortable with that. So that's why now we will operate on our moves, and our move should do the following. We will run for m in moves, and we will say the stack, which is creates from. Then we create remove the last, which is not true. We will remove the first. Well, we select the stack. We can just do that. Stack from, and let's also do the stack to. We can do this here with a get value, which is nicer than stack 2, and then we do a for I in 0 until m.count, and this is then a stack 2 at first stack from remove first. And this, after that, we should have our stacks ready, and we now want to check. So we'll do we'll just join it to string basically. This means we do a crates, which is not sorted, which you'll need to sort. We'll go for the easy way here. Crates.getValue, crates.stack.first, and we'll just take a var solution is equal to an empty string, and we'll just say solution dot plus solution. We'll just take the first element of a stack, add it to the end, and afterwards we return the solution. This should all be covered then. Yeah. Well, then let's give it a run. Most probably will. Let's just see how that works out. We have a line. The line contains a D. This was a stupid mistake. A bit confused. Ah, it doesn't skip it here. So then we want to consume the line and we didn't do that, so this makes sense. Now we should have consumed the line. We have this one. We'll just check back with the example. And we can also just check our crates. They should. And we have N and Z. We kind of have M. So our crates aren't doing particularly well. We'll figure that out later. Now just check our moves. But that doesn't work because, yeah. Group start. We need to skip the first one. Kotlin list skip one. Can I say drop? Give it that a try. Parts are now 1 to 1. A little bit weirdly formatted here, but they are integers, so. And we'll check in our example. 1 to 1. That's good. Then we forget about this. And let's check our moves in total. So we have the moves here. It's from 2 to 1 with 1. It's from 1 to 3 with 3. It's from 2 to 1 with 1, and it's from 1 to 2 with 1. That's fine. But we are still doing kind of bad up here, I guess. Creates still the same weird thing. So then let's go here and rerun the code. So because it's actually creates in line divided by 4 is actually not that good. Because the space in there I can replace 3 with an empty crate. And then we just count the spaces plus 1. How do we have an empty? Do we split here at any point? No, we don't. But the crates in line divided by 4, this kind of makes sense, but it should be then plus 1. But we can also just divide it by 3, could we? Because it's not 4. Now, I'll rather go with this approach here. And just check. Where are we stuck now? Yeah, the thing is, it thinks now. But I don't really care because I don't need to read the full. If it's center crate, I can leave it out. So now let's check how does our crate thing look. We have this is okay. N and Z. P, and we have the DCM here, yeah. We now have our moves. Key is missing in the map. Yeah, that also makes sense because we are here not using the just do a +1 on the I here. And we'll increase that to this one as well. Should we do? I don't like it. I really don't like non-zero indices. So the thing what we do here is we'll subtract the 1 here. CMZ, and we have this solution here. Yeah, because we don't remove the brackets, but we can easily do that. We'll just say substring start index 1, and we don't want to have the 2. Let's give this a try. Part 2. As you watch the crane operator expertly rearrange the crates, you notice the process isn't following your prediction. Some mud was converting the writing on the side of the crane, and you quickly wipe it away. The crane isn't the crane mover 9000, it's a crane mover 9001. The crate mover 9001 is notable for many new exciting features: air conditioning, leather seats, and extra cup holder, and the ability to pick up and move multiple crates at once. Again, considering the example from above, the crates begin in the same configuration. Moving a single crate from stack 2 to 1 behaves the same as before. However, the action of moving 3 crates from stack 1 to stack 3 means that those 3 moved crates stay in the same order, resulting in this new configuration. Next, as both crates are moved from stack 2 to stack 1, they retain their order as well. Finally, a single crate is still moved from stack 1, but now it's crate C that gets moved. This means we now have new example. We'll just copy over that, put this to part 2, add it to our Git, and we'll change this to MCD, and we'll also change our runner to part 2 of level 5. And we have the solving part here. We can reuse the data class. What we'll now need to change is this here. Well, the stacks are fine. Let's just check what we can do for our stack from to remove all collection of string. No elements. No. So we will now remove. How do we do that nicely? We can just put them on a stack. Yeah, we'll try it that way. So the thing what we do is now we'll just create a temporary stack, which will like an array DQ. Call this, well, temporary. And what we do is we push them onto the stack. Dot add first, exactly as we would have done with the other one. The only thing is now, so we just change the order twice. So we put them on a stack, and then we'll pull them from the stack. So we have them just rotating twice, because I couldn't find a method that just takes n elements on top from them And I think this is a kind of nice hack and should work. Oh, let's fire it up, give it a try. So we were correct on this one. Let's say check if you're correct on this one. We are. That's cool. Note, this is not a super nice solution, but well, it was easy to do. So thanks for joining in. See you tomorrow.